Hey, welcome to lesson 3.2, Congruent Triangles. Today we're going to be talking about how I can prove that two triangles are congruent. So how do I know if two triangles are congruent? And remember, congruent means the same size and shape. But I know you know it because you kind of look at it, you're like, oh, those look about the same. But how do you know? Well, I'll tell you, this is how you prove without any reasonable doubt that triangles are congruent. Triangles are congruent if all sides and angles are the equal measures. All right, and what I mean is this. So if these two triangles have all three sides that are the same length and all three angles that are the same measure, then these two triangles must be congruent. Well, so let's make sure of that. So I'm going to go through this and let's list out all the congruent sides and all the congruent angles. Okay? Well, let's see. I know that CA is congruent to DO because they are both 3 feet long, right? So let's just write that out. CA is congruent to DO. Okay? Now I also know that CT is congruent to DG because they're both 5 feet long. So CT is congruent to DG, and I know that because they're both the same length. And finally, I know that AT is congruent to OG because they're both 4 feet long. So AT is congruent to OG. So I proved the sides are all congruent, but now I also show that the angles are all congruent. Well, I know angle C is 58 degrees and angle D, so let's show this. So we know that angle C is congruent to angle D, and notice how I put that congruent mark there. I know that angle A is congruent to angle O because those are also both congruent. Angle A is congruent to O. And I know T, they're both 90. Remember, this is a 90-degree angle if it has that little square there. And angle T is congruent to angle G because they're both 32 degrees. So now I showed that all three sides and all three angles are congruent, so I know triangle CAT is congruent to triangle DOG. And that's because corresponding angles and sides are congruent. And corresponding just means the ones that match up to each other. So like C is corresponding to D, A corresponds to O. So if someone said, prove that these two triangles are congruent, how could you do it? Well, you'd look at it and you'd say, okay, well, I know the three sides are congruent because look, I know RA is congruent to BD because they have this mark, right? And that mark tells me that they're congruent. So let's see, let's prove that the sides are congruent. So RA is congruent to BD. And I know that because they're marked. That tells me that they are congruent. Now I know AP is congruent to DO because they have this mark here. So AP is congruent to DO, right? Because they're marked congruent. And then I know RP is congruent to BO because they have the 3 hashes, right? And so that tells me that these two are congruent because they have the same amount of marks. So RP is congruent to BO. Alright, well now we got to show that the angles are congruent. And you'll look here, but I don't have all my angles, right? This one's 25 and this one's 25. I have one, but then, well, 120 and 35 aren't congruent, so these triangles must not be congruent, right? Like, oh crap, the angles aren't there. Well, actually, you always have to find the missing angle to come to your final conclusion. So if you have these two angles listed, let's find our missing angle. And you might remember we could do that by doing 180 minus 120 minus 25. All right, and that gives me 35 degrees. Okay, so let's write that in here. And then we know 180 minus 25 minus 35. Let's find the missing angle in this triangle. And that gives us 120 degrees. So this is 120. Well, now if I look at this, I could see that, well, look, R is congruent to B, they're both 25 degrees. A is congruent to D, they're both 120, and P is congruent to O. So remember to find all your missing angles first before coming to any conclusions. So let's write that out. R is congruent to B. Angle A is congruent to angle D. And angle P is congruent to angle O. And so that tells me that triangle RAP P is congruent to triangle BDO. And the reason is because corresponding angles and sides are congruent. That's it. If all the sides are congruent and all the angles are congruent, then you know that the two triangles are congruent. Alright, for the second part of this lesson, we're going to learn kind of the reverse of that. What if I told you that two triangles are congruent? So in this case, I am telling you that triangle BEN is congruent to triangle ROK. I want to figure out which sides and angles are congruent, okay? And it's not just by looking at it. So the thing is, when you write a congruent statement, when you see the two things are congruent, the order matters. And what do I mean by the order matters? Well, it's like this. If B is the first letter in the first one and R is the first letter, I know angle B must be congruent to angle R. So angle B is congruent to angle R. And we're going to mark that B is congruent to R. I also know that angle E is congruent to angle O because they're both the second letter. E is congruent to O. And let's use 2 marks now. All right. We need to use 2 because we already used 1 over here. And then finally, angle N is congruent to angle K. And let's use 3 marks because they're both the third letter. All right. Now this also works for sides, so I'm going to clear this out for a second and check this out. I know that BE, the first 2 letters, side BE right here is congruent to side RO. So BE is congruent to RO because they're the first 2 letters. So BE is congruent to RO. They're the first 2 letters. I also know that EN is congruent to OK. So EN is congruent to OK because they're the second letters. They're in the same position. All right. And then finally, I know that BN is congruent to RK because those are both the last letters. B and N is congruent to R and K. So BN, let's use 3 marks now, is congruent to R and K because they are both the last letters. So the order of this tells you which sides and angles are congruent to each other. That order really, really matters. So for example, if I know that triangle ABC, which is right here, is congruent to triangle DEF, I want to find out, okay, so which sides and angles are congruent here, and then I can fill in all the missing sides and angles in this triangle. All right, so let's just start off by filling in which sides and angles are congruent. Well, I know A is congruent to D, so angle A is congruent to angle D. I know B is congruent to E, so angle B is congruent to E. And angle C is congruent to F because they're both the last one. All right, so since I know A is congruent to D, I know D is also 67 degrees. And I know you're thinking, oh hey, those don't look the same. They must be, that's not fair. Well, you know what, I just wanted to show you that just because they look the same doesn't mean they're going to be the same. You should base it on the order. So if A and D are in the first, you put them, that is your congruent angles. Angle B is congruent to E, so B is 92, so that means E must be 92 degrees. And C is congruent to F. So since C is 21 degrees, F is 21 degrees. Okay? Now let's do the sides, all right? Let me just erase all this. All right? I know that AB is congruent to DE, so AB is congruent to DE. So if AB is 17, DE is also 17. I know that BC is congruent to EF, so BC is congruent to EF. All right. So if BC is 20, I know EF is also 20. And then finally, if I know AC is congruent to DF, so AC is congruent to DF. So if AC is 23, DF is 23. And that's how this is done. All right? So remember, this order matters. So for this one, we know triangle MNO is congruent to JLK. We're going to mark the congruent sides and angles. So at this point, it should be pretty straightforward. We know M is congruent to J, so let's mark that. M is congruent to J. We know N is congruent to K, so N is congruent to K. And I know O is congruent to L. So O, we're going to use 3 marks, is congruent to L. Alright, now that's the angles. Let's mark the congruent sides now. Don't forget the sides. So I know MN is congruent to JK. So MN is congruent to JK. I know NO is congruent to KL. So NO is congruent to KL. And I know MO is congruent to JL. MO is congruent to JL. And that's it. That's how you mark them. You can just, and so that's really powerful right there. Just by looking at the order, I can tell which sides and angles are congruent between two triangles, or any figure for that matter. So in this one, these are just basic questions. NO is congruent to what? If I know that triangle MNO is congruent to triangle JALK, if NO is the last two, it must be congruent to KL because those are the last two. And also, what's congruent to angle O? O is congruent to L, right? Because those are both the L, last ones. In our second example, let's try it again. PG is congruent to XZ. Those are our last ones, so it must be congruent to side XL. And Y is congruent to A, because those are both in the middle. So angle Y is congruent to angle A. Alright, so that tells you about the order. We're rocking. Alright, so we've been able to prove congruence saying that all sides are congruent and all angles are congruent. But another way to prove congruence, and this is the second way to prove it, and there's two ways, you must know both ways. We can prove congruence with rigid transformations. Alright? So what do I mean by that? Well, when a figure is transformed with one or more rigid transformations, remember that's a transformation that keeps the size and shape stays the same. Stays the same. An image is created that is congruent to the pre-image. So when I have a rigid transformation, and remember that's translations, reflections, and rotations, those keep the size and shape. So the two figures, the image and the pre-image, will be congruent. So let's look at an example on how to apply this. Triangle ABC, A prime, B prime, C prime, is the image of triangle ABC after a translation. We're going to mark the congruent sides and angles. Well, since this was just a translation, right, we know that these two figures are congruent because it's a rigid transformation. The size and the shape stays the same. So I know that A is congruent to A, B is congruent to B, and C is congruent to C. I also know that the sides stay the same. So AC is congruent to A prime, C prime, A prime is AB is congruent to AB prime, and BC is congruent to B prime, C prime. So I know all the sides and angles stay the same when it's a rigid transformation. Now I'm going to use the properties of rigid transformation to explain why triangle ABC is congruent to DEF. Alright? And this is all you have to say. A translation, alright, is a rigid transformation, a rigid motion, and rigid motions preserve the distance between points. Alright? This is all you have to say. Alright, how can I prove that these two triangles are congruent? I know it's a translation, and a translation is a rigid motion, and rigid motions preserve the distance between points. So when I translate something, any rigid motion, the two figures are congruent to each other. That's all you have to say. And use these exact words. Whatever the transformation is, it's a rigid motion, and a rigid motion preserves the distance between points. Let's take a look at another example. After a rotation of 180 degrees counterclockwise around the origin, triangle XYZ is the image of XYZ. Mark congruent angles and sides. So once again, when you rotate something, that's a rigid transformation. So I know that all sides and angles stay the same. So I know Y is congruent to Y, I know X is congruent to X, and I know Z is congruent to Z. I also know the sides stay lower, so XY is congruent to XY prime, X prime, Y prime. I know XZ is congruent to X prime, Z prime, and I know YZ is congruent to Y prime, Z prime. Right? So everything stays the same. So now that since the angles inside are the same, how can I explain why the triangle XYZ is congruent to triangle XYZ? Sorry, the prime should be there. Let's put those in. Well, it's simple. A rotation is a rigid motion, okay? And rigid motions preserve the distance between points. Okay, and you have to write this whole thing. You can't just say that a rotation is a rigid motion, I'm done. You also have to say that rigid motions preserve the distance between points. Remember, we got to use our high school language now, not our middle school language where it's the same size and shape. All right, final question. All right, this is it. Triangle ABC and triangle DEF are graphed on the coordinate plane. Use the properties of rigid motions to explain why triangle ABC is congruent to triangle DEF. Now, this doesn't tell us the kind of transformation that takes place here, so we're going to have to say it ourselves. So this is what we're going to start off by saying. What kind of transformation would map ABC onto DEF? That's the first thing we have to do. We have to figure out what this is, because it's not given, right? So what transformation? Let's figure that out. Well, what it looks like is a reflection over the x-axis. All right, so this is a reflection over the x-axis. So what we could say is that a reflection, and this is just all from Unit 1, over the x-axis maps triangle ABC onto triangle DEF. All right, so first thing, we had to figure out what kind of transformation took place. Now the second part is now just to use the same language we used over here. And a reflection is a rigid transformation I'm not done. That's not it. And rigid transformations or motions, you can use either word, preserve distance, oh, this is going on, between points. Okay, so how do you do this? If I want to prove that these two are congruent to each other, right, I just say the transformation that could map them onto each other. So a reflection over the x-axis could map them onto each other. And since it's a reflection, I know that's a rigid transformation, and rigid transformations preserve the distance between points. All right, and that's how you do these questions. All right, now that is it for this lesson. I know it was a bit long, but what can I say? It was a lesson that needed to be. So go take a break, ease your brain, and by ease your brain I mean do more independent practice. All right, guys, kiss your mama and tell them you love them, and say that thank you for birthing me, because that's the right thing to do. And then maybe make them dinner. Be a good kid. Come on, go do it. Peace.